Welcome everyone to the Routed Optical Networking webinar. This is part of a series of webinars that we are doing together with Cisco and our partner NEC. We will have two speakers, two presenters for the webinar today. It's Ben from Cisco and Miguel from NEC. Miguel, now to you.
Thanks, Nadia, for introduction. Hi, ladies and gentlemen. Many thanks for watching. I will start now explaining why the need of the concept routed optical networking. We have identified 6 principal reasons for it. Some of them market-related and others more about technical evolution. First one, we move from 1 giga to 10 giga, 40 giga, 100 and 400 giga interfaces, and the cost for the optics we have been seeing for the last 20 years has been increased a lot compared with the router relative core cost. Also, we evolve our networks to have more capacity, but also capabilities, and it made the environment more complex and full of different components and devices fragmentation. With the evolution of 400 gigs, we also saw the need to have interoperability on interfaces, and standardization happened with OpenSR+. Power cost reductions together with sustainability are in mind and is an objective of most of the companies, and Cisco and NEC efforts for a more efficient and clean use of energy are a priority. Fiber reach across the globe is reaching more population every day, so the possibilities to convert services for network simplification is increasing. And last, programmability and automation for making operations easier, decrease human error, and cost reduction is also a trigger for routed optical networking. Ben, could you please continue with going a bit in depth on the RON technology details, please?
Absolutely, Miguel. Thank you very much. And I'll just jump into a couple of those trends that we're seeing to describe why really now is the time that we're going to see routed optical networking go really mainstream across our industry. I think it's related to what we've seen in terms of services previously being kind of fragmented and converged over different IP or even layer 2 access and aggregation networks. And in that case, the optical layer really had a multi-service economy of scale in the sense that it would aggregate multiple routers in that pre-aggregation POP, for example, and then be able to fire out an optimized link northbound towards the core of the network. What we see at the bottom here now is that, and especially driven over in recent years with segment routing, we've seen services converge over a single pre-aggregation network, which means that there's no longer an aggregation benefit to that optical layer. So everything from the router, that single router, or perhaps a double one for resiliency, northbound would be 100% driven over an optical interface, which has helped us as well in the journey to also, let's say, multi-dimensional convergence. Service convergence first, then it makes sense to absorb that optical layer as well into that IP device. With that in mind, and also what you mentioned, Miguel, around the cost importance and the power importance of optics, Cisco have been investing a great deal in vertically integrating manufacturing and design capabilities into our supply chain. So the last couple of really big investments, Luxtera, there was a $660 million approximate dollar investment. They're leaders in the automation of silicon photonics. So using the benefits of silicon that we've seen drive down routing port costs and putting that into the gray optics manufacturing process. And then on the right there, more related actually specifically to this conversation, is the coherent optics leadership that we bring in-house with Acacia. It was approximately a 4.5 billion acquisition for Cisco, massive investment for us, which enables to bring that optimized coherent optics into the long haul. So the DWDM optics we saw one with ZR+ before, that is now in-house at Cisco. Just to say quickly where Luxtera, for example, comes in and Acacia comes in. So we all have in our points of presence or within short haul networks basically what we call grey optics. They're delivering, for example, 1 or 400 gig over a fiber pair, maybe 10 kilometers, all within the same POP. Of course, and that's where Luxtera comes in, and that silicon photonics manufacturing capability. What we get with when we want to actually get multiple links down the same fiber, of course, this is where DWDM technology comes in. This is where we see coherent technologies, of course, and that's where Luxtera both enables a coherent transponder in the middle IP plus optical design, but crucially to really optimize and to pull that technology directly into the router at the bottom there with this routed optical networking layer convergence, we get that coherent capability into a pluggable about this big that then plugs directly into the router, negating the need for that transponder shelf in the middle solution there. And this is this really big game changer. The ZR Plus, there's a multi-source agreement in place. Multi-vendor interop is that the industry is basically getting around this type of optic. And crucially, one thing that kind of held us back with integrating optics is as part of an IP over DWDM architecture, if you knew that term some years ago, was that we needed very specific line cards to deliver that capability. Now, these optics plug into standards-based QSFP DD form factor cages in routers and switches. So you kind of have a do-it-yourself combination line card between long-haul ports and short-haul gray interfaces that we mentioned before, which means there's no special designs. Again, we can standardize over also the same types of line cards being built. And this is probably I would say, at least from a sustainability and business driver perspective, one of the most powerful slides you'll see today. At 100 gig, this sort of technology was saving approximately 6% in power. At 200 gig, we're effectively using a very similar digital signal processor. We managed to get 33% approximate power savings, which drove a few deployments of this type of technology. Then at 400 gig, 68% approximate power consumption savings. It can be lower, it can be even higher in a lot of networks. We'll have to go and model the specific network we're talking about, but approximately 68% power savings is extremely powerful in the industry, excuse the pun, and that's happened at the same time that energy costs have increased. We're also focused on sustainability and building the most sustainable and profitable networks for our service provider and large enterprise and public sector customers. So this is a massive driver that again we really believe is driving that true mainstream deployment of this type of technology. And just to kind of break that down into where those relative power savings are coming from. So the size of these boxes approximates the watt per gig of that particular function. So the router at the top, the grey optic on the left there, which is needed one grey optic, let's say for a 400 gig link on the router, and then one grey optic on the transponder client side of the client port in that transponder shelf. And then in yellow, we have the approximate transponder power in watt to drive that interface. With convergence on the right there, effectively, because a ZR plus optic is very similar actually in power consumption to two grey optics, really you're just negating the external transponder power cost. That can be 100, 150 watts. It varies depending on the transponder line card that you have in place. But it's by removing that cost completely, it's a huge proportional saving, which is where that 68% approximation that you saw on the previous slide resides from. And then crucially, you mentioned it, Miguel, the sort of automation benefits that we have now today with the various tools we have is also an enabler for actually deploying this type of technology. One example is again, it was an acquisition that we made not so long ago in Sedona Systems, which is now part of Cisco, and gives us a main building block in our Crosswork hierarchical controller, which effectively enables you to view the service as it relates to IP layers, as it relates to the optical layer, and as it relates to the physical fiber. And you can, as you can see on the two other kind of screenshots, you get this sort of layered service view, and you're able to visualize that service over that fiber. So you can really manage a multi-layer network from a one pane of glass hierarchical perspective, which really catalyzes the deployment of this type of technology. And it's where NEC a really fantastic partner to actually operationalize a lot of these automation systems, which is really the special source to enable the deployment of these technologies. Zooming a tiny little bit in on the Crosswork network controller, we've seen that there's approximately a 70% reduction in time to operate these networks when you get this type of perspective, an 81% faster time to service, and we're able to fit this into a multi-domain framework. We know that we're going into brownfield environments nearly all the time, and we have to work with other third-party optical controllers, and these can plug into that hierarchical design. And we're not saying that it can do everything. We're saying that in most instances, we maintain an IP controller and an optical controller, and this hierarchical controller sits above and gives you that end-to-end view. So it really, I think, fitting in and flexible to all brownfield environments, really, as we're able to put it on top of almost an agnostic to what's underneath. The last slide I'll leave you with, folks, is what we've been doing a lot of work on to visualize all these end-to-end technologies. You probably look at the Cisco portfolio and our web page and see many different components for service providers or big private WAN networks to utilize. What we've tried to do is actually embed them in an end-to-end architecture, a mass scale network transformation design, which is effectively a blueprint, and you're able to go in there and click on these different areas, click on access, click on routed optical networking to find out more and to see how security and automation solutions fit into that end-to-end design. So with that, Miguel, I would really like you to take us through into that key NEC and Cisco partnership, please.
Many thanks, Ben. Before that, just highlighting the key topics you cover, right? Network evolution with sustainability. It cannot be the other way. Now I'll give a summary of Cisco and NEC business relationship, NEC systems integration capabilities, and also an interesting recent success story about Cisco and NEC RUN implementation. Cisco and NEC have had a business relationship for more than 25 years. Gold partnerships in 1996 in Japan, but in 2021, NEC became global partner of Cisco, and we have been seeing that joint solutions and integrations have made the number of projects to increase in many customers. The expansion of our global partnership made enter into the Global System Integrator Agreement, acceleration of the deployment of 5G IP transport network solutions globally. We also jointly drive new business opportunities for 5G. Cisco complements NEC ecosystem with optimized IP metro access transport and edge cloud computing solutions. Cisco will support NEC customer engagement by offering best-in-class products, proposals, and execution support. And there are agreements to collaborate and enhance joint solutions portfolio in the future. So we can say that our partnership is growing as we scale. There are 4 pillars we Cisco and NEC are maintaining so that our partnership and relevance keep increasing and get beneficial for all our customers. First one is joint solutions. Having individual great and market-proven products in our customers was not enough to add more value together, but integration of our vertical products and solutions and having our 5 ecosystems working together and integrated was the key for recent successes. Our alliance is strategic, and both companies are continuously making efforts to keep it. There is also a single point of contact for engineering and sales for our customers to keep proactive and reactive activities on track and well supported. Both companies have a good track of expert engineers with very wide range of certifications, and we are enhancing that by making them also expert on our joint solutions and businesses. Our global presence in terms of engineers, offices around the globe, and customers that go from service providers to large enterprises and distributors make us to reach almost every kind of network. This is the X-Hall solution suite. X-Hall faces a wide variety of requirements in terms of technologies to be effective. It goes from Open RAN to edge computing by having multi-domain automation and security protection. Main 3 goals are increase the profitability of the network investment, reduce time to market for solution implementation, and service quality enhancements. All this reduces OPEX and CAPEX spent in the network. That is a key objective for all companies. This suite goes from the radio to the core of the data network, passing by the access and metro. IP and optical transport equipment and data center are the main components, backed up with our automation and security solutions that are 2 of the priorities of our customers nowadays. Quality of the products and solutions is important, but the use of it is key so that we can get the best of them and prevent network incidences and outages. That is why professional services need to be aligned and prepared for it. They have focus on customer and market needs, integrated with the system and new ecosystems, and it can only be achieved by experienced engineers that Cisco and NEC have. From the initial project planning and design, following with the test and implementation, and ending up with operations and optimization, our Center of Excellence teams will deploy and maintain RAN in a professional way, given the experts gained in the last 10-20 years. All this across the main 4 domains: IP optical transport, data center, network security, and network automation. One of the biggest and most recent success stories on RAN for Cisco and NEC is a Tier 1 service provider in Latin America, where we have implemented the solution to increase the capacity of the multi-tenant fiber optic neutral network to help accelerate the delivery of the 5G services and enable the Internet of the future, expanding connectivity to reach more areas of the country. This was a brownfield deployment, so one of the first challenges was to go deep and understand the old mature MPLS network they have in place, trying to simplify the architecture and services to be able to apply automation in the simplest way possible to support the imminent capacity increase that 5G would produce. 48 channels of DWDM with 400 gigs, service provision and automation, live bandwidth optimization, and routers and transponder in the same physical layer were the main benefits that are enabling multiple mobile and fixed service providers to cost effectively serve the infrastructure through this new routed optical network service. This is the mature and complex MPLS network we had. From right to left, the mobile access network, followed by aggregation and core, and passing again to aggregation, fixed access network, all different autonomous systems with border routers and using different routing protocols like ISIS, eBGP, and IBGP. With departure from the traditional model where IP and optics were separated, and we had differentiated the router, the OTN switch, and the transporter, all connected with fibers. Then we moved to a convergent model a couple of years ago when we had the IP and optics together, and then to the current final step where we remove the transponder and transport serve to simplify the DWDM infrastructure called Converged Software-Defined Networking Transport Solution, using IP over Ethernet, over fiber, where leg signal amplifiers are needed. This was much more than replacing boxes. This was a transformation in the construction and operations of the network. Through the massive use of technology, we moved to a huge simplification in the access network, deployment of a huge transport capacity. We built an extremely flexible infrastructure. We established an automated platform of network devices and an acceleration of the fixed convergence. Here we can see the building blocks of the solution. On the left, all the access types, micro radio, Wi-Fi, DSL, passive optical networking, and Ethernet that connects to the network by the access per aggregation. Aggregation and core, covering front haul, mid haul, back haul for edge and regional data centers. The whole network is programmable, distributed and dynamic, managed by different Cisco components. EPNN manager for fault and performance management, but also topology and configuration, provisioning, inventory. Cross-board network controller, or CNC, that simplifies service management and operations by bringing visibility, insights, and actions in a closed-loop network optimization environment. Why? That is one automation engine for design and planning used to visualize and optimize IP networks. An ONP, Optical Network Planner, to model and test optical network devices. All this could be managed by operations and business support systems via APIs to meet all customer needs and environments. Then, with this, we are done with Cisco and NEC relationship, NEC systems integration capabilities, and the recent success story in America. Could you please finalize with a call to action?
Absolutely, Miguel. Thank you very much. Exciting times indeed. We've got some great other sessions as well on the platform. If you haven't already started with the executive webinar, that would be where we'd recommend you to have a quick look. We'll leave you as well, again, with the link to the mass scale network transformation blueprint, which is that end-to-end perspective of all the different solutions and how they fit into an end-to-end either service provider network or large private WAN for public sector, large enterprise, utilities, all very relevant technologies that can be applied to deliver the type of sustainability benefits, security benefits, and automated time-saving benefits that we've had a sneak peek at today. So with that, thank you very much for your time, and goodbye.